Hello students! So this video here and this lesson is about the segment addition postulate. So guys, we're not going to take too long to do this, but before we actually jump into talking about the segment addition postulate, we do need to give you guys some basic information just in general that you need to know before we actually talk about the segment addition postulate. Alright, so guys, a line is a two-dimensional figure having no thickness and consisting of an infinite amount of points that extend with a straight path in opposite directions without end. And guys, a line segment is part of a line that has two endpoints, and it consists of all the points between and it has a specific length. So again, guys, a line segment, which is really what this segment addition postulate is referring to. Again, a line segment. Again, a line segment is a part of a line that has two endpoints, consists of all the points between those two endpoints, and it has a specific length. Again, folks, those are the definitions for a line and a line segment. Again, guys, I didn't make up these definitions, but again, if we're going to talk about the definitions of these words, we might as well be specific and use mathematic terminology, right? All right, so thankfully, most of us already know, or at least know what a line looks like and what a line segment looks like, but for those of us who may not, know what a line or line segment look like, we're going to show you. And we're also going to show you how a line or different ways that a line can be named and different ways that we can name or in other words, how we can name a line segment. So we're going to show you what they look like and how we can name lines and line segments as well. Again, folks, for those who did not know, exactly what a line looked like, I believe everyone in my class should enrolled in my class at our school should already know what a line looked like and what a line segment looks like. But just in case there's someone who was wondering, what exactly that looks like. And just in case there was anyone who did not understand how it is that we name lines or how the names of lines are written or how they look when they get named, and also how to name line segments. We're going to go through that real quick. So, guys, again, folks, you can see here in the blue, that's a blue line. You can see on that blue line we've got three points: point E, point L, and point F. Guys, whenever you've got points or the names of points, they'll always use capital letters when they're referring to or when they have the names of points written. Sometimes they call points vertices, depending on what type of geometric figure you're looking at. But again, when you're talking about points or the names of points, they'll always use capital letters. Again, like what you see here: capital E, capital L, capital F. Point E, point L, point F. And so, guys, the blue part, that is a line. The red figure is a line segment. You can see, guys, pretty much that again, within that blue line, there is a line segment, right? And you can see that pretty much it has that. You can see that line segment that's in the blue line, and you can see that it's pretty much. I've pretty much taken that and made it separately, and there you see it separately drawn in red. That same line segment ELF. Okay, but again, you can see here that a line segment is a part of a line. Okay. All right. And again, where a line does not have any specific length to it, a line segment will have some type of specific length. And again, guys, the reason why a line doesn't have any length is because the line never ends. But we know that a line segment does end. A line segment has two endpoints. All right, so let's look at different ways to name lines. So guys, one way that we can name a line is to use a lowercase italicized letter. Now, folks, if you don't really understand what the word italicized means, I really hope that you do. Excuse me. I really hope that you do. Let me try to show you real quick on a Word document what it looks like. I think everybody in my classes, enrolled in my particular classes, know what we mean when we say an italicized letter. But for those who don't, I'm gonna show you real quick, super real quick. Okay, so again, guys, when we say lowercase and italicized, we're talking about the smaller letters. And by italicized, we mean the sort of like a little slanted and kind of fancy. But anyway, just wanted to make sure you knew what we meant by lowercase and italicized. Moving back. So again, folks, for this blue line that we've got here, there's different ways to name it. Again, guys, you can use a lowercase italicized letter. And if you notice here, guys, there's only one lowercase italicized letter that you see here beside the blue line. And so, guys, one way that you could do this is you can name that blue line M. So you can call it line M. That's M as in Mary. Mary had a little lamb. Again, folks, when you are using 2 points, any 2 points on a line, and using that little symbol written on top of that to name a line, guys, you don't have to put the 2 points in any specific order. So again, there are 6 different ways you can name that blue line just based on using any 2 points. You can name that blue line that you see there. You can name it line EL. You can also name it line LE. You can name it line LF. You can name it line FL. You can name it line EF, or you can name it line FE. Okay, guys, just in case what I just said a few seconds ago got completely unrecorded, guys, when you're naming line segments, again, you want to use 2 endpoints. Guys, in this diagram with the red segment here, there are 3 different line segments. In that, there's a line segment with the 2 endpoints E and L. So there's these 2 line segments from E to L. Sorry, this one line segment from E to L. There's the next longest line segment there has the 2 endpoints L and F. And then, guys, the longest line segment that you see there in red is from the endpoint E to F. Guys, I'm going to use the longest line segment there with the 2 endpoints E and F. Okay, folks, again, when we are using two endpoints to name a line segment, we have to use a certain symbol, the same way that we had to use a certain symbol when we use 2 points on a line to name a line. We have to use a certain symbol when we're using 2 endpoints of a segment to name it. So that symbol looks like this, guys. Again, folks, that longest segment there, the segment with the 2 endpoints EF. Again, if we name that, we can name it segment EF, where it looks like that with the little symbol on the top, or we can name it segment FE. Again, guys, the order there doesn't matter as long as you make sure you use the two endpoints. Okay, so guys, just one more thing that you need to know before we introduce the segment addition postulate to you. Guys, whenever you have the two letters like EF, like that, whenever you have the two letters written beside each other without the little symbol at the top, what that means when you see those two capital letters written right beside each other like that without that symbol above it, that means that we're talking about the length of that segment. So for instance, guys, where we have EF here and it's written without the little symbol at the top, we're talking about the length of segment EF. Again, folks, that is the length of segment EF. Okay, so guys, really quickly, we're about to introduce to you the segment addition postulate and what that is. First off, guys, really briefly, some of you may be wondering with that word postulate, right? Some of you might have thought originally, okay, that looks like the word postulate. Yeah, I know what the word postulate means. Yeah, like when I postulate something, I think about something real. But anyway, it's not. That's not what we're talking about here, guys. This is a mathematic term. When we're in the world of mathematics or the world of geometry, which is a type of mathematics, a postulate, guys, is, let's see, how do we put it? A postulate is a statement which is taken as true. And guys, a postulate is kind of widely accepted as true even without proof. And another word that they may use in the place of postulate is axiom. But anyway, we don't have time to talk about all that. But anyway, guys, when we say postulate, we're talking about a type of statement, and really in mathematics, that's what we're talking about, a type of statement that is widely accepted as true, even without proof. Okay, so guys, here's the segment addition postulate. All right, so what it states is, and what it specifically states is, if 3 points, and we're talking about points A, B, and C, if 3 points A, B, and C are collinear, okay, guys, collinear means that those 3 points are on the same line. Like together, like you and a coworker, you work together, right? With somebody, co-worker, collinear, they're on the same line, okay? So if 3 points, A, B, and C, are collinear, and point B is between A and C, okay? Good so far, right? So if 3 points, A, B, and C, are collinear, and point B is between A and C, then guys, what must be true is that AB, remember guys, I just told you that when you have two capital letters written like that without the symbol on top, they're referring to the length of segment AB. So where you see AB here, they're referring to the length of segment AB. The length of segment AB plus the length of segment BC is equal to the length of segment AC. Okay? That's the segment addition postulate. Guys, hopefully that doesn't seem too abstract, but if it does, let me possibly show you or maybe explain it in a slightly different way. So let's say, guys, that you've got a straight line. A line, yes, a line goes on forever and ever and ever, forever. I'm sorry, I don't know who that was. Forever. All right. Anyway, you got a line, a straight line goes on forever, and you got 3 points on that line. Anywhere on that line, you got 3 points. 1, 2, 3. Points A, B, and C are on that line, and it says point B is in between. So the point in between is point B. Point B is in between points A and C. So you got your 3 points on a line, on the same line. Point B is in between points A and C. guys, there are two segments that get created when you do that. Segment AB, two segments created. Segment AB right there. And the other segment, of course, is segment BC, right? Two segments that get created. But really, guys, there are three. Oops, give me a sec. Really, guys, there are three segments there. Not only just segment AB and segment BC, there's the entire segment there, the entire segment from A to C. So there's three segments in total. Segment AB, segment BC, and the entire segment, segment AC, right? So guys, what they're saying is that when you have 3 points on the same line, and in other words, when those two segments are created, those two smaller segments are created, guys, the length of those two smaller segments can be added together to give you the length of the entire whole long segment. So that's why they've got here that the length of AB plus the length of BC is equal to the length of AC. Guys, in other words, folks, when you take the length of these parts here, the length of AB and the length of BC, and add them together, the length of those parts has to be equal to the length of the whole thing. I hope that makes sense. There's not much else I can do to explain that the length of those separate parts, AB and BC, when you put them together, it has to equal to the length of the entire segment, AC. Okay? There's not much else I can do to explain that. Okay? All right, so hopefully that makes sense, because it should be common sense, even though I'm told that sense isn't always common to everyone. But anyway, okay, so guys, so just really briefly, let me just show you real quick. There will be some examples that I'm going to show you in just a little bit, guys. Some of these examples are going to have just numeric values in them, and then other examples are going to have variable expressions. And so let me show you what I mean when I say numeric values. So let's say that we were looking at the segment AB, right? Let's say that segment had a length of 7, right? Yeah. So let's say that segment from A to B had a length of 7. And let's say that the segment from A to C has a length of, I don't know, 18. Okay? So if the length of AB was equal to 7, and the length of AC was, oops, that ain't no C. That's a C right there now. And the length of AC was equal to 18. So one possible example might look like that right there. They may say find the length of BC. Right? Find the length of BC. So guys, again, sometimes they may actually give you the drawing of the line segment. Sometimes they may give it to you in words, like what you see here. They may tell you you've got 3 points, A, B, and C, that are collinear, and they may tell you that point B is between A and C, and you may have to actually draw out your own line segment and then go from there. But anyway, we'll show you examples like this, and so they may say something like find BC. And again, guys, if you were going to do that, and I am going to show you different examples as well, using the segment addition postulate. Let me make sure this thing is recording, because if I'm saying this for no reason, okay, great, awesome, lovely. All right, sorry about that, folks. So if you're going to be using the segment addition postulate, then again, folks, the length of AB plus the length of BC, those two smaller parts there, when you add them together, it has to be equal to the whole thing from A to C. From that, it has to be equal to the length of AC. And so, guys, here, again, folks, this right here, when you just have numeric values, is pretty, I guess, pretty self-explanatory. And guys, some of you might be wondering why I'm writing it like this and literally substituting this. When we're looking at examples where they're not using numeric values, where they're using certain things, and I'm going to erase this, when they're using things like 5x plus 3, you're going to want to do exactly the way that I'm showing you how to do it, or the way that I will show you how to do that. But anyway, folks, so if you, again, guys, if you kind of replace that with what it is, AB is actually 7, right? BC, we don't know what that is. You can either put something like a question mark, or we know that the unknown value is like X. But again, guys, we can just leave it as really we can leave it as BC, because we're talking about the length of segment BC. That's good enough, right? All right, and then this part, of course, is 18. And again, folks, most of us probably knew the answer to what BC was right off the bat. Once I told you that AB was 7 and I told you that AC was 18, you realize right off the bat probably that, okay, this is common sense. 7 plus something has to give me 18, right? Duh, Mr. Starkey, I know the 7 plus 11. All right, some of you might not have been able to tell me that, but anyway, folks, I'm showing you the math behind it, seeing as to how this is a math class, right? Okay, awesome, lovely. So again, folks, BC, yeah, that's not a C. Let's try that again. Again, folks, BC is equal to 11. Wow, that is not an equal sign. BC is equal to 11. And again, guys, I'm going to show you a few examples. Now, you can pretty much count this one right here as your example 1, really. But again, I'm going to show you more examples. You can pretty much count that one right there as your example 1. Seriously. All jokes aside. All right, I'm going to show you a few more examples, and then we're going to call it quits, folks. Okay, so guys, let's look at example 2 here. Let's say that we've got points A, E, and T are collinear with point E between A and T. And you're asked to find TA, and again, we know that's the length of segment TA. Find TA if ET, ET, oh, hold on real quick. Between A and T, Aggie, pride. Hey, all right, find TA if ET, haha, that was a good movie. You guys have to excuse me. I'm very tired at the moment, and so my attention's a little diverted. But anyway, find TA if ET equals 14 and EA equals 17. EA Sports is in the game. Okay, all right. So that's example 2, and we're asked to find TA, the length of TA, if ET equals 14 and EA equals 17. Some of you guys might be saying, Mr. Starkey, what in the world is going on here? Why are they asking us to find something? I mean, they didn't even give us a diagram, Mr. Starkey. They didn't give us a line segment to look at. You're absolutely right, folks. They didn't give you a line segment to look at. And actually, guys, most of your examples on your practice problems are going to look exactly like this. Yeah, my students enrolled in my classes at our school. Yeah. All right. So, in other words, guys, you're going to have to actually draw out your own line segment for these. So you can draw yourself out a little line segment. You know what? I like straight lines. Y'all just gonna have to see my ruler. It's okay. It's all right. I'm a little OCD and I'm not OCD at the same time. It's okay. Maybe we could just say I have OCD tendencies. Sometimes. All right. So again, you're gonna have to draw your own little line segment, okay? And then you're gonna have to place the points in the order that they said place them in. Really, seriously. I mean, that's really it. Point E is between. Okay. Well, which point is between the other two? That one. Really? That's not an E. Okay. Give me just one sec, guys. Gotta make sure that we're recording. Give me one sec. Yes, we are. Okay. Because I hate to be saying this and then have to re-say it again. Okay. Point E is between A and T. Awesome. Okay. So if point E is between A and T, Aggie Pride, A and T. I apologize about that, guys. That's my alma mater. So, yeah. Alrighty. So point E is between A and T. Alright, so again, folks, you have to draw your own diagram and you got to place the points where they need to go. And then, folks, fill in the diagram based on the information that you do have, right? So they tell you that ET, or the length of segment ET, is 14. Well, what do we do with that? You can either kind of draw it sort of separately like this, or you can just kind of put a 14 right here. That's up to you. I'm gonna put mine separately, like what you're seeing right now. Okay. So ET is 14, right? Yeah. Or the length of segment ET is 14. They tell you that EA is 17. So the length of EA is 17. Yeah, let's try that again. It's 17. So you got this part is 17, this part is 14, and they want you to find the length of TA. TA, a teacher's assistant. Wow. Okay. Anyway. All right. So they want you to find the length of TA. So again, folks, with this, okay, how would you write out the segment addition postulate with these segments? How would you write out oops, give me a second. I meant to write segment somewhere in there. Y'all excuse me. Segment addition. There we go. Segment addition, right? So how would we write out the segment addition postulate using those particular points and those line segments that we had, right? So which two segments have to add together to give you the whole thing? All right, that's what you should be asking yourself. And the answer is segment AE, or the length of segment AE, which is that first segment that you see right there, AE, right? The length of that one has to be added to, okay, which other segment is not the whole long segment, right? ET. You know what? That was a good movie. I don't even remember it, but I really don't, besides the fact that it involved the alien and the boy on the bicycle. But you know, anyway, I digress. I'm sorry. All right. So we've got AE plus ET. And so when those two segments are added together, folks, they have to be added together. Those two smaller segments are added together to give you the whole segment. And the whole segment, the entire thing, it goes from point A to point T, right? So AE plus ET equals AT. So the length of those smaller two segments added together equals the length of the entire whole segment. All right, so guys, that's the way that I'd like for you to show your work, or at least start by showing your work. Start off by writing out that segment addition, right? So start off by doing that. Apologize about that not straight line, but it's not gonna get straight. I'm gonna try to get it straight, but it ain't gonna get straight. Not really. Oh, boy, that boy got skills right there. All right, anyway, so I'd like for you to start off showing your work. My students enrolled in my classes at our school, like for you to start off showing your work by writing out that segment addition. Okay, using the points that are in this, or that are in the particular problem that you're doing. Okay, and for this example, that's A, E, and T, right? And using those segments. And then the next thing that I'd like for you to do, guys, is go ahead on and substitute those things there in the place of it, right? So the next thing that I need for you to do when you're showing your work is to go ahead on and make your little substitution. Substitute, okay? You know, go ahead on and do that right now. So go ahead on and do your little substitution. Substitute. Substitute. And plug in those values that you're given, right? So we were given that EA, okay, and that's the same thing as AE, right? EA and AE are the same thing. All right, so EA was 14, right? So we go ahead on and plug that on in, right there. Yeah, that's 14. Oops, okay. Yeah, that's fine. Go ahead on, do your little substitution, do your substituting. All right, so that's 14. ET was my bad, guys. ET was 14. AE or EA was 17. All right. That was 17. So go ahead on and substitute what we do know. And of course, guys, if we're looking for or trying to find TA, which is the same thing as AT, you can leave that written as AT, or you can put a question mark, or you can put a variable like X in its place as an unknown value. But again, it's just as easy for you to leave this as AT, which represents the length of segment AT. Anyway, yeah. All right, so guys, this is really easy here. This one here, 17 plus 14 is 31, right? So the length of AT, which is technically the exact same thing as what they were asking us for, TA, right? Really? TA is 31, okay? That's it for this example here. We're gonna look at a few more examples, and the next few examples that we'll look at are not gonna involve numbers, like actual numbers for the length. The next few examples we're gonna look at where those lengths are given as variable expressions. So instead of having stuff like 17 and 14, we'll have variable expressions. All right. Next up, and these next examples. Oh yeah. And before we go to the next example, and I'm only going to show you actually one more example. Of course, guys, the third thing that I need for you to show in your work, of course, is actually solve or simplify, right? Like what we did. In example 2, all we had to do was simplify that, because 17 plus 14 gave us 31. Sometimes you will have to actually solve, like you'll have to use some algebra, use some inverse operations to find the thing that you're actually looking for. But anyway, guys, all right, next example is coming up. All right, so folks, let's go ahead and look here at example 3. Again, guys, this will be the last example I'm showing you in this video, because this really covers everything that'll be in your practice for the day for segment addition postulate, and this really kind of covers pretty much everything that I'm going over with you concerning segment addition postulate. All right, so let's do this. Points GOD Oh man, that spells God. Hallelujah. All right. Points GOD are collinear with point O between D and G. Find OG. Oh, that stands for original gangster. OG, triple OG. Hey. All right. Find OG if DG equals 5x plus 11. Okay, so find OG if DG equals 5x plus 11. Also, if OG equals 4x plus 2. And if DO equals 8x minus 40. All right, so this has a lot in there. I told you guys, some of the problems that you'll be doing will have only numbers for the lengths like 17 and 14, and I told you some of them are going to have only just variable expressions. Well, guess what? This one only has variable expressions, but it's using the same concept as the previous two examples. So again, folks, the steps that I want you to show, in your work that I'm going to ask you to show, specifically, I'm talking to my students enrolled in my classes at our school. You know this already. Come on. What we going to do? First thing we're going to do is we're going to write out the segment addition. Well, first thing we're going to do, really, now, if you just got it like that, and you don't need to, if you just completely got it like that, and I doubt that any of you really got it completely like that. Anyway, if you just got it like that and you can just visualize how it looks and everything like that without drawing out a line segment, you real good. I can do it for the most part, but I still like to have I still like to have a little visual to look at. I can do it, but it'll take me a lot longer to try to do it without drawing out a line segment. And I'm just being honest, and I'm a math teacher, okay? It'll take me a whole lot longer to try to do it without drawing out my own little line segment. And you know I'm good at math, right? But maybe you don't know, but I'm good at math. I'm just telling you. I can help you get good at math. All right, but anyway, all right, so. All right, again, folks, first thing you're gonna do is draw out a little line segment. Unless you just got it like that. Again, that's up to you. If you feel like, and I don't suggest it, but if you feel like you just got it like that, then feel free to skip this step. I don't suggest it though. Anyway, the parts that I most certainly want you to show when you're doing your work for me. After you either choose to draw this line segment or not. Anyway, it says point O is between D and G. Yeah, that ain't no D. Now it is. Point O is between D and G. That really don't look like no G. Okay, that's better. All right, point O is between D and G. So the first thing I need for you to do in showing me your work is, again, folks, write out that segment addition postulate for me using these points and these line segments. Write out that segment addition postulate. Ooh, that's a sloppy postulate, but you know what? It's going to have to work for right now. Okay. All right, so folks, the way we would write this out in this video, or sorry, this example, DO, okay, plus, all right, so what's the other small part that's being added, that has to be added to give you the entire thing? OG, right? DO plus OG equals DG. The entire segment, wow, really? Equals DG. DG. Alright, so DO plus OG equals DG. Alright, so again, folks, after you've written out that segment addition postulate, again, I'm going to want for you to substitute. Yes, I am. Yes, I is. I'm going to want for you to go ahead on and substitute. And plug in those things that we've been given here. Excuse me, I don't really want that right there. Okay, you got to get moved. Bye-bye. All right, again, folks, next I'm going to need for you to substitute. Substitute in those, and again, folks, they're not numeric values, but substitute in this particular case, these algebraic expressions that we were given. All right, so we were told that OG, okay, well, let me go in order. We were told that DO was 8x minus 40, right? So DO was 8x minus 40. Boom, 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 right? Okay. All right, we still going to have the little plus sign here. OG, we were told that was 4x plus 2. Wow. 4x plus 2. All right. We still going to have the equal sign here. And guys, we were told that DG was 5x plus 11. All right, so we're going to go ahead on and we're going to work this out, right? We're going to solve this equation, right? That's going to be the last thing that we're going to do. We're going to simplify and we're going to solve. Simplify, solve. Simplify and solve. Whatever it is that we need to do to finish solving for what we need to do. And guys, actually, in this one, first we need to solve for the variable. So let me go ahead on and state that, because if we've got algebraic expressions, first you're going to have to solve for the variable. After you solve for the variable, you're going to have to actually plug in that value of the variable. But again, we'll do that after we solve for the variable. Anyway, because again, folks, remember that they are literally asking you to find OG. I'm going to come back to that. Remember that they're asking you to find OG. They're not asking you to find X, even though we have to find X. All right, so let's go ahead on and solve here. All right, so we're going to go ahead on and solve this. And yeah. All right, so let's simplify what we can. Our like terms here, these X's, we're going to put those together. And then, of course, and we're talking about, guys, the like terms that are on the same side of the equation. So let's put the X's together. The 8x and the 4x, that gives us 12x when we put that together, right? 12x. And then when we put the negative 40 together with the positive 2, that gives us negative 38. All right, and then we still got the 5x plus 11 on the right side of the equation. Ooh, okay, we got to hurry up. It's getting late. Still got to have time for these videos to upload. All right, we're going to hurry this up, yeah. All right, let's go ahead and get all our variables together. 5x minus 5x. Here we got 7x left over. All right, we still got the minus 38 there. It is equal to 11. Okay, so let's go ahead on and get the constants on the other side of the equation. Add 38 to both sides. There we go, add 38. That gives us 49. All right, so there. Now we've got 7x left over. And on the left side and on the right side, we've got 38 plus 49. 38 plus 49 is 87. Okay, that is not true, guys. My bad. We already, yeah, I wrote something twice by mistake. I'd already worked out what 11 plus 38 is. And again, guys, 11 plus 38 is 49. You see what happened when you try to move real quick? That's fine. All right, 11 plus 38 equals 49. Awesome. At least I had my stuff written down so I can see where I had my mistake. Great. All right, divide by 7 on both sides. Divide by 7. All right, here we go. X equals 49 divided by 7, which is 7. All right, now, guys, we've solved for the variable, which is x equals 7. But, guys, remember, we were not asked to find x. We were asked to find OG. So that's what we need to do, guys. We need to find OG. So, guys, we need to take that. Yeah, okay, I didn't mean to do that again. We need to go ahead on and take that expression for OG, and we need to plug in. We need to plug in our x value into that expression for OG. So last thing here, you guys, is to go ahead on and plug in or substitute again substitute the x value, or the value of the variable, the variable's value, find value of the variable. Y'all know what I'm talking about. That value that we just now found for the variable. We need to plug that in. We need to plug that into the expression that we're actually trying to find. Okay, into the expression for the length we are trying to find. For the wanted length, the length that we actually want to find. Alright, and guys, in this particular case, that wanted length, as I've already said, is OG. Okay, yeah. Excuse me, guys. That length is OG. Alright, we got to hurry up and do this, yeah. Alright, so let's plug that in for OG. Alright, so guys, we know that OG is equal to 4x plus 2. So again, guys, we need to substitute that x there, and we need to plug in the value that we just now got, which in this case was 7, right? So that's 4 times 7 plus 2, all right, and 4 times 7 is 28, right? So that's 28 plus 2, and 28 plus 2 gives us 30. So guys, our answer here is that OG, the length of OG, is equal to 30. Now guys, sometimes, depending on what type of practice you're doing, sometimes, like when you're given variable expressions, they won't just ask you, excuse me guys, excuse me 1 second, we gotta move this. We don't have to, but we're going to. Sometimes guys, they will ask you not only just to find the length of one of these expressions, or find the length of one of these segments, like OG, but sometimes guys, they'll ask you to find the length, to actually find the length of all of them. So guys, if you were asked to find the length of all 3 of those segments, then you wouldn't just have to plug in the value of x into one of them, but you would have to plug in the value of x into all 3 of those expressions. But anyway, guys, that's it. That's all I got for you. This is the last example where we were given variable expressions instead of just numeric expressions. Yeah, I don't like that. Get rid of that. Bye-bye. Okay, I thought I was deleting it. Bye-bye. There we go. All right, that's better. That's it, folks. I do hope that this has been helpful to you. That's all I got for you. See you later. Adios. Bye-bye. Au revoir.